All right, good morning. It's 8 o'clock. Welcome everybody to class. I'm going to start this morning with some announcements. At this point, I expect everyone to be on time. First of all, lesson 17.1, which you've had out for a while because I had to teach a lesson, I think in 3 parts, is due on Tuesday. Excuse me just a second. Yes. I'm teaching a class right now, so can I call you back? Okay, thank you. Okay, bye. All righty, sorry about that. So when I got my tooth fixed the other day, I had to get a temporary crown and the crown came off on Saturday. So I got to go back to the dentist. Anyhow, back to what I was saying. Lesson 17.1, you've had it out for a while, is due Tuesday at 9 p.m. And the next exam won't be until I finish teaching 17.3. So I'm talking about 17.2 today. So the next exam will have 3 lessons, 17.1 through 17.3, and that'll be when I'm finished teaching 17.3. I decided to have no vocabulary quiz, like I said last time, and I usually give a graphing quiz in standard form, but I'm not doing that. So make sure that if you have any questions about naming an angle in standard position, that you ask me. The new lesson, which is 17.2, I haven't given it a due date yet because I don't know when I'm going to finish. But if you're interested, 17.2 is page 847 through 850, and that's 1 through 26 all. We'll see where I get to it today. Anyhow, last week, I started talking about I started defining and evaluating the basic trig functions. And I brought up what Ms. Fresco went over in geometry, and that was right triangles and looking at SOHCAHTOA, which is a mnemonic device, which has nothing to do with math. But the trig functions defined using right triangles. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. And you found that, hopefully you did it. And those definitions are based on the location of the angle. So you have to see where the actual angle is in order to use those definitions. All right, so right after that, I started talking about the unit circle. So this is a different way. This is the second way that the trig functions are defined. So one is looking at right triangles. The other is looking at the unit circle. And some teachers have students memorize the whole unit circle and all the angles, and I'm not going to do that. So I'm going to have you memorize the first quadrant only. And from that, we're going to use angles to determine all the other answers and definitions. So I'll show you what I mean today. All right. How do the boards look? Mariana, can you see the boards okay? Yeah, okay. So I'm going to go back to the unit circle real quick because this is important. So unit circle meaning the radius is 1. It is shown in the coordinate plane. And I was saying be cognizant of the quadrants. So quadrant, we have an ordered pair of positive, positive, negative, positive, negative, negative, and positive, negative. And you do want to know that these points are no longer defined on the unit circle as XY. They're defined as cosine of theta and sine of theta. And I told you this is that X comes before Y in the alphabet, like C comes before S in the alphabet. So basically what we're doing doing here is we're superimposing three pictures. So one picture is divided into 6 parts. The second picture, pi is divided into, and the third picture, pi is divided into 3 parts. So it's 3 pictures. This isn't one picture, this is 3 pictures superimposed. And I was specifically talking about these angles called common angles. And so basically, in degrees, these angles are 30 degrees, 45 degrees, and 60 degrees. And you saw Ms. Fresco look at these as right triangles by drawing a segment straight down and creating a right angle. We're not going to do that. So in radians, which we've talked about, and this would be 0 degrees down here, and this would be 90 degrees up here. In radians, we would have 0 radians. This would be pi over 6 radians. This would be over 4 radians. And this would be pi over 3 radians, because this first picture was divided into 6 parts, was divided into 4 parts, and the third picture was divided into 3 parts. And of course, dividing pi in half would be pi over 2 radians. Okay, now, let's memorize this. These are the reference angles, okay, in degrees and radians. And you're going to hear me talk about the reference angles in a minute. I'm going to define it, and this is going to be a very important concept. All right. So not only do you have angles, but the angles are associated to a point on the unit circle. And so this point would be radical 3 over 2 and 1/2. This point would be radical 2 over 2 and radical 2 over 2. And this point would be 1/2 and radical 3 over 2. Right 1, 0, because the radius is 1, so right 1, 0, and this point would be 0, up 1. You must memorize this, and you must understand this like walking or breathing. You have to just know this. I mean, just got to be able to come up with these just super quick. Now, last week, I showed you how to hold your hand up here and come up with the ordered pairs that the angles are associated to. So I don't know if you got this or not, but if you hold your hand up and you put all of these angles up here, the points have a denominator of 2. So you just have to remember that. They all have a denominator of 2. If you put your first finger down, you can come up with the first ordered pair. So look at my hands, and it has to be the left hand. This would be radical 3 over 2 and 1/2. So see the radical 3 and then over 2 and then 1/2. If you put down your middle finger, you would have your radical 2 over 2 and your radical 2 over 2. And then finally, if you put down your ring finger, you would have 1/2 and radical 3 over 2. So this is another device that you can use to actually, when you take an exam or what, you can just hold your hand up. It doesn't work if you use your right hand. It doesn't work if you turn your hand over and look at your palm. You have to turn it over like you're looking at a ring. So you have to turn your hand over like you're looking at a ring, and you can come up with these different ordered pairs by looking at your hand. I'm going to leave that up there, and I'm going to go into evaluating trig functions, special angles. But the first thing I want to talk about is the reference angle. So I'm going to write it right here because I'm going to use the other board. Right here. Okay, a reference angle is a positive acute angle in the first quadrant. Very important that you know this definition. Because first of all, it's positive. Second of all, it's acute, which means it's between 0 and 90. So positive acute angle in quadrant 1. So what we want to evaluate, which means find a number, the trig functions, by using, this is what it says in your book, the quadrant, and the reference angle. So for example, and I'm going to work some problems with radians right now because it's easier than degrees. So for example, and I need to write down the steps. You know what? I'm going to write down the steps later because I don't have room. I need more boards. I want everything written up here at once. I want to refer to this. So cosine of 16 pi over 3. All right, we want to know what the number is. Let's evaluate cosine of 16 pi over 3. Well, what we want to do is we want to find the reference angle. So with radians, it's easy to cheat. It's different with degrees. It's harder. But what you could do with finding the reference angle here is you can look at the denominator. And you could say, hey, the denominator's 3, so that means my reference angle is pi over 3 in the first quadrant. So remember that with the reference angle, you want to get a positive acute angle in the first quadrant only. So what would be a reference angle to this? And this, by the way, is how you denote a reference angle, and you call that theta prime. So that little tick mark means prime, and it refers to the reference angle. So the reference angle would be pi over 3 radians. That's the first thing you do, is you find the reference angle in quadrant 1. And now we're going to evaluate the reference angle. So you can hold up your hand and you put down your finger for pi over 3, and cosine is x, right? So see my finger up here? Cosine of pi over 3 would be 1/2. And you can look over here, but you must memorize this. So cosine of pi over 3 is 1/2. And now what we do is, to figure out the exact answer, we have to put ourselves in the right quadrant. Because this answer isn't in quadrant 1 necessarily. This answer is in quadrant 1, but we need to know where the actual angle is. So remember I was talking about the horizontals and knowing that over here is 3 pi over 3, and over here would be 6 pi over 3, and over here would be 3 more, which would be, what, 9 pi over 3? Notice I'm not even close. So what you want to do is you want to use these horizontals to figure out where this angle is, rather than counting pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So let's see if we can do this. All right. So we start at 0. The first one, the first half revolution would be 3 pi over 3. I'll write this up here for now, so you know what I'm doing. Over here, this first half revolution would be 3 pi over 3. When I wrap back around, one full revolution would be 6 pi over 3, or 2 pi. And then you have 9 pi over 3, which is 3 pi. 10, 11, 12 pi over 3 would be 4 pi. So see, like I said before, how the evens are over here and the odds are over here. So I'm still not close to 16. So this would be 13, 14, 15 pi over 3, and now I'm really close. And so by looking at this, we can determine that this angle is going to be in quadrant 3. And so now what we do is we look at the sine of cosine in quadrant 3. So cosine in quadrant 3 would be negative. So those are the 3 steps. I'll write them down later, but that's basically how you're going to evaluate a trig function. So I'll repeat. This angle right here is an angle that it's not in quadrant 1. So what you want to do is find a reference angle theta prime. And with radians, we can cheat and look at the bottom. So if it's a 3, the reference angle is pi over 3. If it's a 4, the reference angle is pi over 4. If it's 6, the reference angle is pi over 6. So remember that the reference angle is a positive acute angle in the first quadrant. After you find the reference angle, we evaluate the reference angle. And I just showed you a way to use your hand by looking at your ring on your left hand, and you bring down this finger for pi over 3, and we know that cosine is x, so cosine of pi over 3 for cosine of that angle is 1/2. After you find the reference angle, that's not our answer. Our answer is cosine of 16 pi over 3. So what you have to do is you have to locate 16 pi over 3 in the unit circle, and you have to figure out which quadrant 16 pi over 3. And I showed you a quick way of doing it by looking at the horizontals. So you know that your unit circle is divided into 3 parts. This would be pi over 3, 2 pi over 3, 3 pi over 3. It's divided like this, right? Three parts on the top and 3 parts on the bottom. So you see I'm doing this, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3. But you didn't see me do that when I taught it, because what I'm doing is I know that the evens are over here, 0 pi, 2 pi, 4 pi, 6 pi. I know the odds are over here, pi, 3 pi, 5 pi. So I'm cheating to get to where I want. All right, anybody want to ask me a question right now? So if you have any questions right now, ask me about unit circle or about creating a trig function. If you do understand this, we're going to be doing this for a while. You must understand this to go on. It's impossible to move forward without knowing what I'm teaching today.
Ms. Birch?
Yeah.
I'm kind of confused on the second step of the evaluate.
Okay. All right. How about I'll do another problem, and then you can, since I already erased it, let me do another problem. You can, when we look at it. So I'm going to do another radian problem. So this time we're going to look at sine of 7 pi over 6. So the first step is to find the reference angle. And like I said, with radians, it's easy. You can cheat. Degrees, you can't. I'm going to do the degrees in a minute. But look at the bottom is 6, right? So what would the reference angle be? Pi over 6. Okay, so now what we want to do is we want to evaluate the reference angle. So we want to evaluate sine of pi over 6. So what we've done right now is we have taken the original problem and we put ourselves in the first quadrant and figure out the problem on the step. So what you do is you can hold your hand up And now we have the unit circle divided into 6 parts. So if the unit circle is divided into 6 parts, pi over 6 is here, right? So what is the y value of pi over 6? It's not radical 3 over 2, it's 1/2. All right, was that Max? Was that you talking? Hello, who was talking to me?
Yeah, I was talking.
Yeah. Did you get that, Max?
Yeah, I got that a little more now. Then
Do you see how to use your hand though to come up with the value?
yeah, you gotta.
So you can either just memorize it, radical 3 over 2 and 1/2, radical 2 over 2, radical 2 over 2, 1/2, and radical 3 over 2. But I'm trying to get you to look at your hand in case you get confused, that you can always resort to your hand to get the ordered pairs. So we're not done, because what we did is we evaluated the reference angle. But we don't want the reference angle. We want pi over 6. So if you look back over here and disregard everything up here, top into 6 parts. See, it's divided into 8 parts. You want to divide it into 6 parts. Let me write it over here. So if you divide the top into 6 parts, pi over 6 radians, 2 pi over 6 radians, 3 pi over 6, 4 pi over 6, 5 pi over 6. This is 6 pi over 6 radians, right? So where is 7 pi over 6? It would be in quadrant 3. And the sign of 3 are negative. So what is sine, which is the y value? What is the y value in quadrant 3? Negative. So last time I didn't write it like that, but so don't get confused. So here we're evaluating the reference angle, and then we turn around and use that to evaluate our actual. Further what's going on here. All right, here's what's going on. Okay. That from here to here is pi over 6. And I made it dotted because that's not what we're trying to find. So it just so happens that this ordered pair is radical 3 over 2 and 1/2. Well, see this angle? And the one that matches up here, and the one that matches up there? Those all have the same ordered pair. So this, which is 5 pi over 6, this guy is 7 pi over 6, and this guy is 11 pi over 6. And I can show the angles if I want. Okay. All of those angles have the same ordered pair. So in other words, 5 pi over 6 is radical 3 over 2 and 1/2. And this guy is radical 3 over 2 and 1/2. And this guy is radical 3 over 2 and 1/2. The only difference is that they have, depending on what quadrant they're in, they change signs. So in this quadrant, you have a positive. In this quadrant, you have a negative cosine and a positive sine. In this quadrant, you have a negative. And in this quadrant, you have cosine positive and sine negative. So rather than having me Have you memorized the whole unit circle? What I'm doing is I'm saying, you memorize quadrant 1. I'm going to have you find the reference angle to these other angles. So in other words, by knowing pi over 6, you know all of these other angles. You know the ordered pair for 5 pi over 6. You know the ordered pair for 7 pi over 6. You know the ordered pair for 11 pi over 6. So by memorizing pi over 6, you know the other ones. Why? Because they look like pi over 6 from the horizontal. See how this angle looks like pi over 6? See how they all look similar to pi over 6? All right, Max, does that help?
Yeah, that helps.
Okay, let's do another problem. And then we'll go to degrees. Now, by the way, in pre-calculus, well, you guys could put all this in the calculator, but I recommend you don't do that, because if you really want to learn from me right now, you have to do these by hand, because in pre-cal, you're going to be quizzed all the time on this stuff, and you must, when it says evaluate, you must do it by hand. You cannot use a calculator. So you cannot use a calculator. Let's look at some more. So tangent of 11 pi over 4. All right, so let's find the reference angle. Like I said, we can cheat and look at the denominator. So if the denominator is 4, we know the reference angle is pi over 4. That's easy, right? So now we're going to evaluate tangent of pi over 4, which is the reference angle. And we know that tangent is y over x, right? Or opposite over adjacent. Two different definitions. It's either y over x or opposite over adjacent. So if you hold up your hand, your ordered pair is radical 2 over 2 over radical 2 over 2. Which is 1. So now what we want to do is we want to evaluate our actual angle, which is 11 pi over 4. So in other words, we already know the answer is 1. We just need to determine the sign of it, positive or negative. So I'm going to draw this picture. So now you're dividing the unit circle into 4 parts on the top and the bottom. And we can count one by one, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. But I'm not going to do that. What I'm going to do is I'm going to say, okay, that's 0 radians. And we know that this is pi, which would be 4 pi over 4 radians. And if I go a full revolution, it's going to be 8 pi over 4 radians. And if I go another half revolution, 4 more would be what? 12 pi over 4 radians? Well, see how 12 pi over 4 is near 11 pi over 4? So if this is 12 pi over 4, would this be 11 pi over 4? One back. I'm not talking about these right here are for the horizontal, not this guy. Okay, so what's going on here? Well, we know the ordered pair for pi over 4 is radical 2 over 2 and radical 2 over 2. So do you realize that this ordered pair for this point is radical 2 over 2 over radical 2 over 2? And this guy is radical 2 over radical 2, radical 2 over 2 over, and radical 2 over 2. And this guy is radical 2 over 2 and radical 2 over 2. The only difference is this guy's ordered pair is negative radical 2 over 2 and positive. So when you look at tangent of 11 pi over 4, wouldn't it be y over x a positive divided by a negative, which would be -1? right? So it's positive divided by a negative. This is quadrant. Now. Quadrant 2 is x negative, y positive, and a positive divided by a negative for tangent is negative. All right, any questions? I'm going to do a couple more. This is really important stuff right here. Still haven't done the degrees yet. Okay, that right there, that's a quadrantal angle. And if you're going to do this, the reference angle, you really need to do the reference angle. I mean, you could figure this out without doing this. All the evens are over here, right? Over on this side. So this would be 0, 2 pi, 4 pi. Well, what's the order here? Isn't it right 1, 0? Well, what's the x value? 1. So for quadrantal angles, I don't know if you want to do it's a waste of time to do a reference angle. You're trying to evaluate. Just use common sense. Quadrantal angle, it's either right 1, 0 up, 1, 0, or 0 down 1, and you can figure out cosine and sine from that. Let's do an angle. Let's do sine of negative pi over 6. That's not a reference angle. Remember, a reference angle has to be positive acute. So if you were going to find a reference angle, it's not negative pi over 6. Your reference angle would be positive pi over 6. And then you would evaluate the reference angle, sine of pi over 6. So you can hold up your hand. You know that pi over 6 is down here. So what is the y value of sine of pi over 6? It's 1/2. So now we're going to evaluate the actual angle, which means we just need to know what quadrant we're in. So isn't negative pi over 6 down here? Clockwise rotation. So if you go clockwise rotation, isn't that quadrant 4? And in quadrant 4, the signs are positive, negative. So what is the sign of negative pi over 6? A lot of negative 1/2. So that's all you're doing, is you're evaluating the reference angle, and then you're finding the actual angle by looking at the quadrant. And sure enough, if you look over here, this is negative pi over 6, right? Well, the ordered pair would be like that one, square root of 3 over 2, and negative 1/2. Let's do some degrees. These are harder. And the reason why they're harder is you have to figure out what quadrant you're in right away, because you can't cheat and look at the denominator like the radians. lost my piece of paper. All right, so here we go. What if we want to find the cosine of 480 degrees? It's more than one revolution. So we want to find the reference angle. And so let's take a look at this. Okay, this is half a revolution is 180 and a full revolution is 360. If I go another 180, what do you have? You have 360 plus 180. What's 360 plus 180? 540. So that means that if we went 360 plus 90, that would be 450. So 480 is somewhere between 450 and 540. So right away, we know it's in quadrant 2. Write that down here. You know, quadrant 2 is negative, positive for the ordered pair. Like, okay, well, where is it though? It's 30 from 450, right? So it's there. So that means our reference angle is, it's going to be the 60-degree angle. Because since it's 30 away from 450, it would be 30 away from there. Remember, this is 30, 45, 60, right? So our reference angle is going to be the 60-degree angle, and the ordered pair is 1/2 and radical 3/2. So if we want to evaluate cosine of 60 degrees, we'll hold up our hand and say cosine is 1/2. A lot of 1/2s today. So when we evaluate cosine of 480, all we do is look at the x coordinate in quadrant 2, which is negative. So, oh my gosh, we came up with negative 1/2 again. You guys are starting to think that's the only answer we have. So it's a little more tricky. Now, well, obviously there's going to be angles that don't match up to these, but right now what we're doing, we're looking at reference angles of the common angles. So you're not going to have anything weird like 15 degrees, but in trigonometry you will. You will be asked to evaluate cosine of 15 degrees, and we need special formulas for that. So in order to do that, we would need a sum and difference formula. And there's a whole bunch of those. So right now, we're just doing the common angles, not a big deal. Let's do another one of these. Let's do a negative angle. Let's do sine of negative 150. So once again, we have to figure out kind of where we are because it's difficult to figure out the reference angle. So let's look at this. This would be 0 degrees. This would be negative 180 degrees. And this would be negative 90 degrees going clockwise, right? Well, isn't negative 150 somewhere in quadrant 3? And quadrant 3 is negative, negative. So the question is, where is negative 150? Well, he's 30 degrees from 180. So once again, we're looking at a 30-degree angle. So the reference angle would be 30 degrees with the ordered pair of radical 3/2 and 1/2. So if you want to hold up your hand, we're looking at sine, which is 1/2. Got to go slower though. Let's go one step at a time. So the reference angle is 30 degrees. And we want to find the sine of the reference angle, which is 1/2. So to find the sine of the actual angle, We just have to put ourselves in the right quadrant. Oh my gosh, look at this. Once again, sine is negative. This is negative 1/2. I'll probably play the lottery today. I can't believe how many problems I have with an answer of negative 1/2. Okay, I will put the steps up and I will make a couple of other notes. Does anybody want to ask me any questions about this before I erase it? So here's what I don't want. I don't want you after the lesson to ask me after I erase it. I don't want you to come to the workshop on Wednesday and ask me. I want you to ask me now while everybody's here. So I want to kill 5 birds with 1 stone. Okay, so if you have a question, ask me now. Because the question Max asked, I actually hadn't explained, you know, what these different angles look like in the different quadrants. So that was really critical that I was able to explain that. So there is no bad or wrong question. So anybody want to ask me a question about how to use your hand to come up with the ordered pairs, anything about the reference angles, or how to come up with the other angles? Any questions? Now, eventually, when you get really good at this, you're not going to do those steps. You're just going to know that the sine of negative 150 is negative 1/2. So it's almost like you're going to do the steps in your head, and you're just going to know. Right now, we're just kind of eating the baby food. We haven't learned how to walk yet, so I'm showing you a step-by-step process. But pretty soon, this step-by-step process is going to be intuitive. And you're going to be able to just come up with them that fast. First thing I want to do is show you the steps. This is the steps for using reference angles. To evaluate trig functions. The first step is to find the reference angle. We call it theta prime, and it is in quadrant 1 because reference angle is defined as a positive acute angle, which is an angle in quadrant 1. The second thing we're going to do is we're going to find the function value for theta prime. So in other words, evaluate the reference angle. The third step is use the quadrant. Where plane theta, that's the original angle. So use the quadrant where theta lies to prefix the sign, plus or minus. So you're using the quadrant where the actual angle lies, its terminal side, to prefix the sign. So right now, the reference angles, the main ones you have to know is you have to know pi over 3 of 30 degrees, which is radical 3 over 2 and 1/2. You need to know 45 degrees or pi over 4, which is radical 2 over 2 and radical 2 over 2. And you need to know 60 degrees or pi over 3, which is 1/2 and radical 3 over 2. You must know that. So make sure you memorize that as soon as possible. couple of other notes. The values of the trig functions of a given angle theta are the same values of the trig functions of the reference angle theta prime. So the values of the trig functions of a given angle theta are the same values of the reference angle theta. A function value of the reference angle theta prime is always positive. The same value for theta may be positive or negative. Okay, so basically what I'm saying here is that the values of the trig function in quadrant 1 are the same values of the values of any trig function in any quadrant are the same values as the reference. A function value of the reference angle is always positive because it's a positive angle in the first quadrant, and the same value for just our regular angle theta could be positive or negative depending on the quadrant. All right, very, very important. I spent a lot of time going over it. I'm going to do a few more things here, but you got to make sure you have this down. That was the first objective. Everything is going to build from this. The next objective is actually evaluating using a calculator, which you cannot do unless it specifically says. So anytime you can evaluate a trig function by hand, you must. If you're taking a written exam from me, if you use a calculator, I won't give you credit for it. You must only use a calculator now when asked to. So this is evaluating a trig function using a calculator. Okay, now, why do we need a calculator? Because we know nothing about 23 degrees. Okay, we know about 30 degrees, 45 degrees, 60 degrees. We know about 90 degrees. But we don't know about 23 degrees. So we're forced to use a calculator. Now here's the deal. You gotta make sure you're in the right mode. So on your calculator, it's next to the yellow key and it says mode in white. You wanna go to your mode and make sure you're in degree mode. In a minute, when you see me radians, you have to make sure you're in radian mode. So let me just tell you what always happens. What always happens is people get all the wrong answers because they're in the wrong mode in the calculator. So I'm just warning you now, make a note, highlight it, put it in red, make sure you're in the correct mode when you're using the calculator. So you're not used to doing that, but you have to get in the habit now. All right, so anyhow, if you put this in the calculator, what's the cosine of 23 degrees? Can someone tell me, please? Can you unmute yourself and tell me? The cosine of 23 degrees. Somebody? I got 50 of you here, so somebody might mute yourself. It's a cosine of 23 degrees. Cosine of 23 degrees?
0.92050.
Yeah. Just gonna leave it like that and pay attention to how they want you to round. About 0.92. Let's go to the tangent of 114 degrees. I can't evaluate that on the unit circle. We don't know anything about 114. So you're using the keys, the trig keys on the calculator. So they're in white. Do not use the yellow keys. Those are the inverse keys. So you're using sine, cosine, and tangent. You're making sure you're in degree mode and just give me the answer. So what's tangent of 114 degrees? Negative.
2.246.
246, so it's about negative 2.25. And then we have the sine of negative 237 degrees. We know nothing about that. Can't find that on the unit circle. So what's the sine of negative 237 degrees? Is it about 0.839? Yes, no?
Yes. Yes.
Okay, so let's go to radians now. Okay, now change your calculator to radian mode. All right, so make sure your calculator's in radian mode. You're going to put in sine of 1.7 pi. And the pi key is second up arrow. So see the pi key in yellow? So it's second up arrow. Second up arrow, right? Okay, so what did you get when you put that in the calculator?
Negative 0.80901.
It's about negative 0.81. We have the cosine of 5 pi over 8. So once again, you want to make sure you're in radian mode. And you found the pi key, okay? So what's the cosine of 5 pi over 8? It's a negative something.
Negative 0.368.
Yeah, that's it. Okay, one more. Uno más. Tangent of -7 pi over 11. We don't know anything about that in the unit circle. So in the unit circle, we have denominators of 3, 4, 6, 2, nothing with 11. So we would have to resort to using the calculator. So what would that be? It's about what?
$2.1896.
Yeah. Shoot, that's about 2.19. All right, I'm going to stop there. Anybody have any questions about anything? Didn't get very far. Therefore, you will not see a due date until I have about 6 more pages of stuff. I did teach the most important thing. Make sure you get this down. How to evaluate the common trig functions using reference angles. Make sure you understand that. It's really critical that you understand that. Okay, so I'm going to say goodbye. I'm going to turn off my recorder, but if you have questions, I can hang out for a minute. Just have a good day, okay? Go ahead.
Is this lesson 17.2 still?
This is 17.2. Okay, I'm going to turn off the recorder. I'll take more questions.